Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study Math, Science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 10 Arithmetic Progression. We have already discussed the concepts of arithmetic progression, how to find the nth term of an AP in our previous class. If you haven't watched that video, go watch it first. Here in this class, we'll be solving more questions from exercise 10B. Hope you all are ready with your pen and papers. Let's solve together. Let us first take an example. If 8 times the 8th term of an AP is equal to 15 times its 15th term, find its 23rd term. This is not a direct question. Here neither the first term is given nor the common difference is given. Nothing is given. Okay, we have to find them. What is given? 8 times the 8th term, T8. What is T8? A plus n minus 1 into d. Tn is equal to a plus n minus 1 into d. This is the general form. Therefore, T8 will be equal to a plus 8 minus 1 into d. That is, T8 is equal to a plus 7d. Now, what is given? 8 times the 8th term. How to find 8 times 8th term? We have to multiply on both sides with 8. 8 into T8 is equal to a plus 7d into 8. Okay, that is 8 times the 8th term is equal to, removing the brackets and multiplying, we get 8a plus 7 into 8. 7 into 8 is 56, 56d. Okay, we got 8 times 8th term. 8 times 8th term is 8a plus 56d. Now, the second part, 15 times its 15th term. 15th term is T15 is equal to a plus 15 minus 1 into d. That is a plus 14d. We got T15. 15th term is a plus 14d. Now, 15 times 15th term means we have to multiply on both sides with 15. 15 into T15 is equal to a plus 14d into 15. 15 times 15th term is equal to, removing the brackets and multiplying, we get 15a plus 14 into 15. 14 into 15 is 210, 210d. Now, what is given in the question? 8 times 8th term of an AP is equal to 15 times 15th term, which means this and this are equal. 8 times 8th term, T8 is equal to 15 times 15th term, T15. Okay, from this and this, consider these two equations. The left hand sides are equal. Therefore, right hand side should also be equal. Here in the right hand side, we have 8a plus 56d. In the second equation, right hand side, we have 15a plus 210d. Now, bringing all the a containing terms to one side and d containing terms to the opposite side, we get 8a minus 15a plus 15a, when taken to this side, becomes minus 15a, is equal to 210d minus 56d. 8a minus 15a is minus 7a is equal to 210 minus 56. We get 154, 154d. From this, we are going to make an equation for a in terms of d. What do we get? A is equal to 154d divided by minus 7. This negative can be taken to the numerator. And 154 divided by 7. What is 154 divided by 7? It is 22. We get minus 22d. A is equal to minus 22d. Now, what do we need to find? This is the relation connecting A and D. We need to find the 23rd term. 23rd term, that is T23 is equal to A plus n minus 1 into D. Here n is equal to 23. A plus 23 minus 1 into D. Okay. Now we have A is equal to minus 22D. T23 is equal to A is minus 22D. 23 minus 1 is 22 plus 22D. Okay, then what is the 23rd term? 23rd term is equal to minus 22D plus 22D, which is equal to 0. Therefore, the final answer, 23rd term of this AP, 23rd term of this AP is equal to 0. Got it? First, we have to convert this statement into a mathematical expression. After that, solve. We are not getting the exact value of A and D in this question. We are making an equation which is in terms of A and D. Then substituting this value of A to find the 23rd term. Got it? Next example, find the sum of all natural numbers between 20 and 80 which are divisible by 3. Numbers divisible by 3. We know 3, 6, 9, then 12, 15, 18, etc. are numbers divisible by 3. Now check the condition. Find the sum of all natural numbers lying between 20 and 80. We have to select numbers which are divisible by 3, is a natural number and lies between 20 and 30. What are the numbers? It begins from 21. 3 into 7 is 21. Then 24. 3 into 8 is 24. 3 into 9 is 27. Then 30. 3 into 10 is 30. Etc. Up to 80. Is 80 divisible by 3? No, right? Then check the previous number, which is 79. 79 divided by 3. Is this possible? To check if a number is divisible by 3, sum up the numbers. That is, here we have 79. Add 7 and 9. 7 plus 9 is 16. Check if 16 is divisible by 3. We know 16 is not divisible by 3. Now check the previous number. 78. What is 7 plus 8? 7 plus 8 is 15. We know 15 is divisible by 3. 3 into 5 is 15. Therefore, we can take 78. 78 is the highest number which lies between 20 and 30 and is divisible by 3. This goes up to 78, which means 78 is the last term and 21 is the first term. We have A is equal to 21 in this case. First term, A is the first term. Last term, L is equal to 78. Okay. L is 78, A is 21. What is the common difference in this case? Here, 21, 24. Second term is 24, first term is 21. Difference between these terms? 3, correct. Difference D is equal to 24 minus 21 or 27 minus 24 or 30 minus 27. Whatever it is, you will be getting 3. We got the common difference 3 in this case. Now, we need to find the number of terms n. N is equal to question mark. What is the formula to find the last term? L is equal to A plus n minus 1 into D. Here we have used L because we know the last term. Nth term is the last term in this case. Okay. Now substitute the values. We have L is equal to 78. 78 is equal to A. A is 21 plus N. N we don't know. Therefore, put as it is. N minus 1 into D. What is D? Common difference D is 3. Okay. Now, here we have 78. Here we have 21. Taking this 21 to the opposite side. 78 minus 21 is equal to N minus 1 into 3. What is 78 minus 21? We get 57. 57 is equal to n minus 1 into 3. Okay. Now I am interchanging them because we have to get the variable containing term in the left hand side just for our comfort. Okay. n minus 1 into 3 is equal to 57. When you shift them, what happens? This positive becomes negative and this positive becomes negative. We can cancel these negative, okay? N minus 1 into 3 is equal to 57, which means n minus 1 is equal to 57 divided by 3. What is 57 divided by 3? N minus 1 is equal to 19. Yes, 57 divided by 3 is 19. What is n? N is equal to 19 minus 1 taken to the opposite side becomes plus 1. Therefore, n is equal to 19 plus 1, 20. We have 20 terms. Okay. Starting from 21, 24, 27, 30, etc. up to 78. And this 78 is the 20th term of the AP. Got it? Clear? Let us solve problems from exercise 10B. Here we have the first problem. Question 1 of exercise 10B. In an AP, 10 times of its 10th term is equal to 30 times of its 30th term. Find the 40th term. Okay, we know to find the nth term of an AP. Yes, what is the formula? We have Tn is equal to A plus n minus 1 into D. Here, A is the first term, D is common difference, n is number of terms. In this question, what is given? Neither A is given nor D is given. We need to find the 40th term. Only a condition is given. What is it? In an AP, 10 times of its 10th term. How to write 10th term? T10. What is T10? A plus n minus 1. Here, n is equal to 10. 10 minus 1 into D, or T10 is equal to A plus 9D. Given 10 times of its 10th term. How can you get the 10 times of 10th term? 10 times. We have to multiply 10 on both sides. Okay. This is how you get 10 times 10th term. Yes. That is 10 T10 is equal to 10 into A plus 9D. Okay. We got 10 times 10th term. Next is equal to 30 times of its 30th term. How can you write 30th term? T30 is equal to A plus 30 minus 1 into D. N minus 1 becomes 30 minus 1 into D. Or T30 is equal to A plus 30 minus 1 is 29. Correct. 29D. Now, 30 times of its 30th term, which means we have to multiply 30 on both sides. To get 10 times 10th term, we multiply 10. To get 30 times 30th term, we are multiplying 30. Okay. 30 T30 is equal to 30 into A plus 29D. Okay. Now, it is given that both of these are equal, which means 30 T30 is equal to 10 T10. Okay, what is 30 T30? 30 times 30th term. That is 30 into A plus 29D is equal to 10 times 10th term. What is 10 times 10th term? This one. 10 into A plus 9D. Okay. Yes. Now here we have 30, here we have 10. The zeros can be cancelled. Okay. 30 by 10 is 3. That is what we are doing here. Now multiplying, removing brackets and multiplying, we get 3A plus 29 into 3. That is 87D is equal to 1 into A plus 9D. A plus 9D. Now bringing all the terms to the left hand side. We get 3A plus 87D minus A A becomes minus A, 9D becomes minus 9D. Minus 9D is equal to, what will be remaining here? 0, correct. 0 will be remaining here. Okay, 3A minus A. 3A minus A is 2A. Next, 87D minus 9D, that is 78D plus 78D is equal to 0. Now, I am taking a common factor from this. 2 is common. 2 into A plus 39D is equal to 0. I can write like this. Or A plus 39D is equal to 0 divided by 2. I am taking this 2 to the opposite side. Here it is multiplication. The opposite side becomes division. We will be getting A plus 39D is equal to 0. Okay. Now, where am I going to use this? We need to find 40th term. Yes, we have a general form Tn is equal to A plus n minus 1 into D. We need to find 40th term, T40. T40 is equal to A plus n minus 1 into D. That is n40 minus 1 into D. Or T40 is equal to A plus 40 minus 1, 39, 39D. Okay, we got T40 is equal to, or the 40th term is equal to A plus 39D. Here we have A plus 39D is equal to 0. From the condition given, we have reached at A plus 39D is equal to 0. Then what is T40? What is the 40th term? If the 40th term is A plus 39D, we have already got A plus 39D is 0, which means the 40th term is equal to 0. In this case, 40th term of the AP is equal to 0. 40th term of AP is equal to 0. Clear? From the given condition, the first thing and the second thing, they are equal. From that, we have got A plus 39D equal to 0. Now, what is the 40th term? 40th term is A plus 39D. Therefore, we got 40th term equal to 0. Clear? Let's move on to the next problem. Problem number 2, question 2 of exercise 10B. How many 2-digit numbers are divisible by 3? What are the numbers divisible by 3? We will be having 3, 6, 9, 12, 15, tables of 3, 18, etc. Now, the condition is we need only 2-digit numbers. Here 3, 6, 9. They are not 2-digit numbers. Okay. Then the first term will be 12. Yes. A is equal to 12. Okay. What is the common difference in this case? We are adding 3 with each term. 12 plus 3 is 15. 15 plus 3 is 18. We are adding 3, which means the common difference D is equal to 3. Now, up to where? We need only 2-digit numbers. 2-digit numbers ends at 99. The largest 2-digit number is 99. Is 99 divisible by 3? Yes, 99 is divisible by 3. 99 divided by 3, we get 33 as quotient and remainder is 0. Therefore, this pattern goes till we reach 99, which means the last term or the nth term is 99. Tn is equal to 99. Okay. Or we can write this as the last term. L is equal to 99. We have a formula, right? Last term L is equal to A plus n minus 1 into D. What do we need to find? How many 2-digit numbers are divisible by 3? Which means we have to find the number of terms n. Yes. All other quantities are known. We know what L is. In this case, L is 99. What A is 12 and D is 3. Then easily we can find and substitute the values. L 99 is equal to A 12 plus n minus 1 into D. D is 3. Okay. Bringing this 12 to the opposite side, what happens? Plus 12 becomes minus 12. 99 minus 12 is equal to n minus 1 into 3. 99 minus 12, we get 87. 87 is equal to n minus 1 into 3. Or we can write this as n minus 1 into 3 is equal to 87. Just interchanging. Bringing the left hand side to the right hand side and right hand side term to the left hand side. Okay. Usually we keep the variable containing terms in the left hand side. Only for that purpose I am rearranging this. N minus 1. Here we are multiplying 3 with n minus 1. Bringing this 3 to the opposite side, it becomes division. 87 divided by 3. Or n minus 1 is equal to, what is 87 divided by 3? We get 29. Okay. Then n is equal to 29 plus 1, which is equal to 30. We get 30 terms. 30 terms. We start with 12, 12, 15, 18, etc. There will be 30 terms to reach 99. All these numbers are 2-digit numbers and divisible by 3. Got it? Here we have the next problem. Problem 3, question 3 of exercise 10B. Which term of AP 5, 15, 25, etc. will be 130 more than its 31st term? In all these questions, here they are not asking us to directly find what A is, what D is with all other quantities given. We have to think. Okay. Here we have an AP 5, 15, 25, etc. What is the first term in this case? A is equal to 5. Common difference? 5, 15. 15 minus 5. Second term minus first term. We get 10. Third term minus second term, 25 minus 15. This is again 10. Confirm this is an AP. Okay. We got D is equal to 10. Now what is given? Which term of this AP will be 130 more than its 31st term? Let us take it as the nth term. Nth term of AP is 130 more than 31st term. We are considering nth term as a term which is 130 more than 31st term. How can you write 31st term? T31. T31 is A plus 31 minus 1 into D, or that is A plus 30D. We got T31 is equal to A plus 30D. From our given condition, we can write Tn is equal to 130 more than 31st term. 31st term is T31. 130 more than. How can you write 130 more than? We have to add 130 plus 130. Okay. Similar questions we used to do in our previous chapters. Remember? Yes. Same thing we are doing here also. We are adding this 130. 130 more than means we are adding 130 to this. Now, we have T31 is equal to A plus 30D. Also, what is Tn? Tn is equal to A plus n minus 1 into D. General form. Substituting Tn is equal to A plus n minus 1 into D and T31 is equal to A plus 30D. What do we get? A plus n minus 1 into D is equal to A plus 30D plus 130. Okay. This A and this A can be cancelled. Same term is there in the left hand side and right hand side. What is remaining? Here we have ND minus D. Removing the brackets and multiplying. On this side we have 30D plus 130. Okay. Now bringing all the D containing terms to one side. What do we get? ND minus D minus 30D is equal to 130. Or we can write N minus 1 minus 30 into D is equal to 130. We know the value of D. D is equal to 10. Substituting n minus 1 minus 30 is minus 31. N minus 31 into D is equal to 130, or n minus 31 into D, that is 10, is equal to 130. Okay. N minus 31 is equal to 130 divided by 10. I am bringing this 10 to the opposite side. We can cancel these zeros. We get 13 here, which means n is equal to 13 plus 31, that is equal to 44. Value of n is equal to 44. Nth term is 44th term. Okay. Here 44th term will be equal to 130 more than 31st term. Clear? Next, problem 4, question 7 of exercise 10b. For what value of n the nth term of AP 63, 65, 67 etc. and the nth term of AP 3, 10, 17 etc. are equal to each other. Nth term of both these APs are equal. This is given. What is the first AP? In the first AP we have terms. First term 63, 65, then 67 etc. Here what is first term? A is equal to 63. Common difference D. D is equal to second term minus first term. 65 minus 63, which is equal to 2. We got the first term and the common difference. Now how to find nth term? Tn. Tn is equal to A plus n minus 1 into D. Put the values of A and D here. Then Tn in this case will be equal to A plus 63 plus, we don't know what n is. Keep it as it is, n minus 1 into D. D is 2. Okay. That is 63 plus, removing the brackets and multiplying, we get 2n minus 2, or that is equal to 61 plus 2n. Here the nth term is 61 plus 2n. Now the second AP. Second AP is 3, 10, 17 etc. In this case, we have A is equal to, first term is 3. What is the common difference? D is equal to second term minus first term, 10 minus 3, which is 7. Or third term minus second term, 17 minus 10, which is again 7. We got A and D. We need the nth term, Tn. Tn is equal to A plus n minus 1 into D. Put the formula wherever you need. Okay. Don't miss it because it carries a mark. A plus 3 plus, we don't know n minus 1 into D. Here D is 7. Therefore, Tn is equal to 3 plus, removing brackets and multiplying, we get 7n minus 7. That is equal to 3 minus 7. 3 minus 7 is minus 4. Minus 4 plus 7n. Here Tn we got minus 4 plus 7n. In the first case, we had Tn is equal to 61 plus 2n. Okay. Left hand side is equal. Given that nth term of both these APs are equal, then right hand side should also be equal. Let us equate. First, we have 61 plus 2n is equal to, from the second we have minus 4 plus 7n. Taking all the variable containing terms to one side and constant to the opposite side, we get 2n plus 7n becomes minus 7n. 2n minus 7n is equal to minus 4, 61 taken to the opposite side, minus 61. 2n minus 7n, that is minus 5n, is equal to minus 4 minus 61, minus 65. Then n is equal to this negative and this negative can be removed. We will be having 65 divided by 5. What is 65 divided by 5? 13, correct. Therefore, n is equal to 13. Okay. Which means the 13th term of the first AP and the second AP are equal. Got it? Next, problem 5, question 10 of exercise 10B. Determine the value of k for which k square plus 4k plus 8, 2k square plus 3k plus 6 and 3k square plus 4k plus 4 are in AP. When do we say a given set of terms are in AP? There should be a common difference, right? Here we are taking this as the first term, this as second term and these as the third term. In that case, the difference between the first and second term should be equal to difference between the second and third term. As they are in AP, this difference will be equal. Yes, what is the difference between the first and second term? We'll call it D1. D1 is equal to second term minus first term. Here the second term is 2k square plus 3k plus 6 minus first term is k square plus 4k plus 8. D1 equal to, distributing the negative sign, we get 2k square plus 3k plus 6 minus k square minus 4k minus 8. Okay. 2k square minus k square is k square plus 3k minus 4k minus k plus 6 minus 8 minus 2. Therefore, we got the difference between the first and second term D1 is equal to k square minus k minus 2. Next, we will find the difference between the second term and the third term. We will call it D2. D2 is equal to third term minus second term. What is the third term? Here we have 3k square plus 4k plus 4 minus second term is 2k square plus 3k plus 6. Next, removing the bracket and distributing the negative sign. We get D2 is equal to 3k square plus 4k plus 4 minus 2k square minus 3k minus 6. Okay. Here we have 3k square minus 2k square, which is equal to k square. Plus 4k minus 3k is plus k plus 4 minus 6 minus 2. Therefore, D2, difference between the second term and third term is k square plus k minus 2. Now, they are in an AP. Therefore, common difference D1 will be equal to D2. What is D1? D1 we have determined, which is k square minus k minus 2 should be equal to D2 k square plus k minus 2. Here we have k square, here again we have k square. Cancelling k squares, minus k plus k. Taking this plus k to the opposite side, minus k minus k. Okay, plus k becomes minus k is equal to, here we have minus 2. Taking this minus 2 to the opposite side, it becomes plus 2. Minus k minus 2k is equal to minus 2 plus 2 is 0. Then what is the value of k? K is equal to 0 divided by minus 2, which is equal to 0. 0 by minus 2 is 0. Got it? When you put the value of k is equal to 0 here, we will be getting this in AP. Fine. Next, problem 6, question 11 of exercise 10B. If A, B, C are in AP, show that 4A, 4B and 4C are in AP. This is the first question. And the second one, A plus 4, B plus 4 and C plus 4 are in AP. Let's solve the first one. We have to show that 4A, 4B and 4C are in AP if A, B, C are in AP. First one, given A, B, C are in AP, which means the second term minus first term should be equal to the third term minus second term. There is a common difference. we can write B minus A is equal to C minus B. Yes, this is the common difference. This is also the common difference. Difference between the first and second term is B minus A. Difference between the second and third term is C minus B. From this we can write, I am taking this minus B to the opposite side and minus A to the opposite side. When minus B is taken to LHS, it becomes plus B. B plus B is equal to C. Minus A taken to the opposite side, it becomes plus A. This can be written as 2B is equal to A plus C. Okay, 2B is equal to A plus C. Now, we have to check if 4A, 4B and 4C are in AP. If 4A, 4B, 4C are taken, what is the difference between second term and the first term? We can prove that they are in AP only if the difference between 4A and 4B, first term and second term, is equal to the difference between third term and fourth term, that is 4B and 4C. Let us see what the difference between the first term and second term is. Here the second term is 4B and the first term is 4A. Okay, 4B minus 4A, that is equal to 4 into B minus A. Yes, you can write it as 4 into B minus A. Now what I am doing is, here this is equal to, I am taking a 2 outside and the remaining 2 is distributed inside. It becomes 2B minus 2A. Okay, 2B minus 2A. I am writing like this. We know what 2B is. 2B is equal to A plus C. Now substituting it here, 2 into 2B is A plus C. A plus C minus 2A. Okay, that is equal to 2 into A minus 2A. A minus 2A is minus A. Then we have a plus C, or this is equal to 2 into C minus A. We got 4B minus 4A is equal to 2 into C minus A. Okay, this is the difference between the first term and the second term. Now we have to find the difference between the third term and second term. If they are equal, then they are in AP. Here we have third term 4C minus second term 4B. This can also be written in this form. Yes, we are taking 2 outside, then 2C minus 2B. What is 2B? We have 2B is equal to A plus C. Substituting here, we get 2 into 2C minus 2B. 2B is A plus C. This minus is common, A plus C. That is equal to 2 into 2C minus A minus C. Removing this bracket, okay, and distributing this negative sign, which is equal to 2 into 2C minus C, that is C. Then we have a minus A. Therefore, we got 4C minus 4B is equal to 2 into C minus A. Also, 4B minus 4A is equal to 2 into C minus A, which means here RHS are equal. Therefore, LHS should also be equal. We can write 4B minus 4A is equal to 4C minus 4B. From this we can conclude that is here we have a common difference. Common difference is there, therefore the terms 4A, 4B and 4C should be in AP. Therefore they are in arithmetic progression. Understood? We are proving that the common difference, the difference between the first term and second term is equal to the difference between second term and third term, from which we can conclude that 4A, 4B and 4C are in AP. Got it? Now we will solve the second part. In the second part, we have to show that A plus 4, B plus 4 and C plus 4 are in AP. If A, B, C are in AP. Same steps. If A, B, C are in AP, we can write second term minus first term is equal to third term minus second term. Here A is the first term, B is the second term and C is the third term. From this we will be getting B plus B is equal to A plus C. Just what we did before, taking this minus B to the opposite side and minus A to the opposite side. 2B is equal to A plus C or B is equal to A plus C divided by 2. Okay. B will be equal to A plus C divided by 2. Now here we have to show that A plus 4, B plus 4 and C plus 4 are in AP. If they are in AP, again second term minus first term should be equal to third term minus second term. Here the second term is B plus 4. We will see what is the difference between the second term and first term. B plus 4 minus A plus 4. B plus 4 minus A plus 4. That is equal to, here we have a plus 4 and this is minus 4. It becomes B minus A. Plus 4 and minus 4 can be removed. Now we have B is equal to A plus C divided by 2. Substituting here, A plus C divided by 2 minus A. Next step, taking LCM. Here the denominator is 1. LCM will be equal to 2. 2 in the numerator, A plus C into 1 is A plus C. Then minus 2 into A, 2A. That is equal to A minus 2A is minus A plus C divided by 2. Or B plus 4 minus A plus 4 is equal to minus A plus C divided by 2 can be written as C minus A divided by 2. Okay. So this is the difference between first term and second term. Similarly, we find the difference between the third term and second term. Third term is C plus 4. Second term is B plus 4. C plus 4 minus B plus 4 will be equal to plus 4 minus 4 can be removed. We will be having C minus B. Substituting the value of B, A plus C by 2 here, we get C minus A plus C divided by 2. Taking LCM, we get 2 here. Multiplying 2C minus A plus C. 2C minus C. This becomes 2C minus A minus C divided by 2. 2C minus C. 2C minus C is equal to C. Then you have a minus A divided by 2. This is C plus 4 minus B plus 4. Okay. Now check them. Second term minus first term is equal to C minus A by 2. Third term minus second term is also equal to C minus A by 2. RHS we have equal, which means LHS should be equal. Therefore, B plus 4 minus A plus 4 is equal to C plus 4 minus B plus 4. That is, second term minus first term is equal to third term minus second term. Therefore, we can conclude that A plus 4, B plus 4 and C plus 4 are in arithmetic progression. Clear? Same procedures that we have done in the first question. Only difference is there we have taken 2B is equal to A plus C for substitution. Here we are taking B is equal to A plus C divided by 2 for substitution. Okay. Next problem 7. Question 13 of exercise 10B. Fourth term of an AP is equal to 3 times its first term and seventh term exceeds twice the third term by 1. Find the first term and the common difference. From the first statement, check this statement. Fourth term of an AP is equal to 3 times its first term. How can you convert this into a mathematical statement? Fourth term of an AP, that is T4, is equal to 3 times its first term. First term is represented using the letter A. 3 times 3 into A. Okay. First part. Now what is T4? How can you write the fourth term? A plus n minus 1 into d. Here n is equal to 4. 4 minus 1 into d, or that is equal to a plus 3d. We got T4 is equal to a plus 3d. We have from the question T4 is equal to 3a and also T4 is equal to a plus 3d, general form of the nth term. Comparing them, we get 3a is equal to a plus 3d. Left hand sides are equal, therefore right hand side should be equal. 3a is equal to a plus 3d. Bringing a to the opposite side, we get 3a minus a is equal to 3d, or 2a. 3a minus a is 2a. 2a is equal to 3d. We can write a is equal to 3d divided by 2. Okay. Keep it aside. Next statement. Here, 7th term exceeds twice the 3rd term by 1. Twice the 3rd term. 3rd term is T3. Okay. Twice the 3rd term means 2 times T3. 7th term exceeds twice the 3rd term, which means 7th term is greater than 2 times 3rd term by 1. Okay, we can write this as T7 minus the difference between the 7th term and 2 times 3rd term is equal to 1. Yes, or we can write this as T7 is equal to 2 times 3rd term plus 1 exceeds. Yes, T7, 7th term is equal to a plus 7 minus 1 into d. 3rd term is T3. T3 is equal to a plus 3 minus 1 into d. What is a plus 7 minus 1 into d? 7 minus 1, 6. This is a plus 6d. And this is a plus 3 minus 1, 2, 2d. Okay, we got T7 and T3. Substituting, here we have T7. T7 is a plus 6d. A plus 6d minus 2 times T3. T3 is a plus 2d. A plus 2d is equal to 1. Okay, that is a plus 6d minus 2a minus 4d is equal to 1. Removing the brackets and multiplying. A minus 2a is minus a. Then 6d minus 4d plus 2d is equal to 1. Here we have an equation for a. A is equal to 3d divided by 2. Substitute it here. What do we get? Minus 3d divided by 2 plus 2d is equal to 1. We have minus 3d divided by 2 plus 2d is equal to 1. Taking LCM, denominator we get 2. Here it is 1. Crossing 3d into 1 is 3d. We have a minus sign, minus 3d. Plus 2d into 2, which is 4d, is equal to 1. Taking this 2 to the opposite side, we get minus 3d plus 4d is equal to 2. What is minus 3d plus 4d? D. Which means minus 3d plus 4d is d. D is equal to 2. We got common difference, d is equal to 2. We need to find the first term a. There is a relation, a is equal to 3d divided by 2. Yes, substitute the value of d here. We get 3 into 2 divided by 2. Cancelling 2, we get 3. A is equal to 3. Therefore, first term a is equal to 3 and the common difference d is equal to 2. Clear? That's all for today. In today's class, we have solved many questions from exercise 10B. Hope you all were able to solve the questions. There are a few more questions which you can practice on your own. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.